All right, and we are coming to you live from Waterbury, Connecticut. It is 4 o'clock p.m., prime time, and I got multiplication on my mind. Huge shout out to everybody tuning in, and I want to give a special shout out to all my fourth grade students. I'm going to drop a beat one time for my fourth graders. As for all of you, huge thank you to for all of you tuning in. You watching this video after hours, getting that extra work in, it is going to pay off. Even if you don't see it right now, it is going to pay off in the long run. Guarantee you that. Every math problem we do, everything in life, every multiplication problem we complete, every sentence we write, every basket we score, we are leveling up. The more you work at something, the better you get at it. That's for all aspects of life. All right. So now this video right here is focused on multiplication. The big question, how do we use a bar model to write equations? How can we use a bar model to write equations? Now, what they mean by when they say write equations, they basically mean just write a multiplication problem. Write a multiplication problem to represent the bar model. So I am going to give about 4 examples for how to do that. I'm going to write the multiplication problem that goes with 4 different bar models, and for each one, I'm going to give you 3 different strategies to solve the problem. All right, so if you notice this bar model, we have a 4, and then we have 3 boxes. Now, with all of these bar models, for some reason, they have a singular box at the top, and then they have groups of the same box at the bottom. I don't know why they have a box at the top like this in the model. Why they have a box at the top, that's kind of, don't understand why they do that. Maybe it's possibly because they want you to be aware of what one group looks like. But we really don't even need to focus on that top box. You just focus on the bottom box. Here, pretend that top box doesn't exist. All right. So the bottom box, we have 3 different squares. So we have 3 different groups, and we have 4 in each group. So basically, for each of these bar models, you ignore the top box because I don't know, we don't need that. But looking at the bottom box, basically you count the number of groups, and you use the number that's in each group to write the equation. So there's 4. 4 is the number in each group, and then there's 3 total groups. So the multiplication problem would be 4 times 3. 4 times 3 would be the multiplication problem here. Now, there's a few different ways to go about solving that problem. So I'm going to break that down. Let me 3 different strategies here. Okay, strategy number 1. Here's one strategy you can use is you can count by 4s. So 4 times 3, that basically means that you're adding the number 3 4 times. That's one strategy you can use. So you would add the number 3 4 times. So 3 plus 3 equals 6. We just added the number 3 twice. 6 plus 3 equals 9. We just added the number 3 3 times. And 9 plus 3 equals 12. All right, we added the number 3 4 times. We got 12. Another strategy you can use if adding and counting by 3 is a little challenging for you is you can draw circles and you can or squares. Well, let's just say circles. You can draw circles and you can put a certain amount in each circle. So 4 circles, and then I'm going to put 3 X's in each circle. 1, 2, 3. All right, and then you count the total number of X's. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. A third strategy you can use is you can just draw, you can use X's, you can use circles, you put it in rows. So you can draw 4 rows of 3. So that's 1 row of 3. That's 2 rows of 3. That's 3 rows of 3. And that is 4 rows of 3. And then you count the total number of circles. There's 4 rows of 3 circles, but we got to find the total number of circles to get our answer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, and we have our answer. 4 times 3 equals 12. Let me write that too a little neater. It should be neater than that. All right, now I'm going to do another one. All right. Let me erase this right here. And draw another model now. All right. So now we are working with the number 5. Now, again, I don't know why this top square is up here. It might just be to show you what one group of 5 would look like. So I don't know what the purpose is for having the top square up there, but we can just kind of pretend that the top square is not there. And just focus on this. All right. So now we have to write a multiplication problem for this bar model. So there are 2 in each group. There are 2 groups, right? We have 2 squares, and the number in each square is 5. So the multiplication problem that would represent this group is 2 times 5, because we have 2 groups of 5. So now I am going to show you the three different strategies for solving this problem. All right. I'm not always going to go in the same order with the strategies. All right. So one way to do this is to take an object, make 2 rows of 5. So I drew circles last time, but you can make X's, whatever the item is. But let's say I'm making X's. So I'm going to make 2 rows of 5 X's. So I have 2 rows of 5 X's. Now I got to count the total number of X's to find the answer. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so that's one way to go about doing it. Another way, you can draw two big circles because it's two groups of 5. So you can draw 2 circles, and you put 5 in each group. Make sure when you're drawing your X's, do not draw them like this. You draw them like this, it'll be very, very easy to miscount. You don't want them bunched up together. You want them far enough away from each other where it's clear to see. You want them separated so you can tell them apart from each other. Because if you draw them too close together, it's very easy to miscount. So again, this is just another illustration. Just another same basic thought process, just another way of going about it. So we have 2 groups of 5 X's, and we count the total number of X's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Notice all these strategies, they get you the same answer. It's just you're going about it differently. Now, last strategy, 2 times 5. That means that you're adding the number 5 2 times. That's just another way of writing 5 plus 5, basically. So if we add 5 plus 5, 5 plus 5 equals 10. 2 times 5 also equals 10. So our answer for this multiplication problem is 10. All right. I am now going to do another one. 2 more demonstrations. I like this setup. I'm going to leave this here. All right, so we have this bar model. So we need to determine what multiplication problem does this bar model right here represent. All right. So again, I am now going to solve this problem. I do not know why the top box is there. I think that my belief is that the top box is there just to show you what one group would look like. Just to show you the difference between one group of 6 and multiple groups of 6. That's why I believe the box is there. But we don't need it to figure out what the multiplication problem is. So we're not going to focus on the top box. We're going to pretend that top box isn't even there. We're just going to focus on this right here. So we're going to count the number of boxes. 1, 2, 3, 4. 1, 2, 3, 4. So we have 4 boxes. And what number do we have in each box? 6. 6 is the number in each box. So we have 4 times 6. So now I'm going to go about solving that multiplication problem in 3 different ways. All right, so I'm going to make 4 groups of 6. I'll use tallies this time. You can use, it doesn't really matter what item you use, but I'm going to put 6 tallies in each circle now. So again, to figure out the answer, we have to find the total number of tallies. So now I'm going to count the total number of tallies. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So I believe our answer is 24. I am going to use 2 other strategies as well. Now, when you do this, you don't have to use all 3 strategies and solve it all 3 ways. You can just pick the strategy that works best for you. But I wanted to show you all multiple strategies. So whichever one you feel most comfortable with, you can use. All right. So the answer was 24. I am going to do 2 other strategies just to make sure, just so you have all the strategies available. So another thing you can do, make 4 rows of 6. So I'm going to use X's this time. And I'm going to make 4 rows of 6 X's. That's 1 row of 6. That's 2 rows of 6. That's 3 rows of 6. And that is 4 rows of 6. All right, now I'm going to count total number of X's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. All right, so it ended up being, I'll write the digit up here. So both strategies ended up with the same answer, 24. All right, last way to go about it. So again, when you see the problem 4 times 6, that means that you're adding the number 6 4 times. Let me write that a little bit neater so y'all can see. So 4 times 6, that means that you're adding the number 6 4 times. So I got something in my shoe over here. All right. So 6 plus 6 equals 12. So I just added the number 6 twice. Now I'm going to add 12 plus 6. 12 plus 6 equals 18. Now I'm going to add 18 plus 6. 18 plus 6 equals 24. Just added 6 4 times, and our answer is 24. So 4 times 6 equals 24. All right, one more problem, and then it's time to play some basketball. All right. We'll rock out with 7. Okay, final problem. You have to write this bar graph as a multiplication problem. So here we have groups of 7. The top box really is just an example to show you what one group of 7 would look like. I believe that's what the purpose of what that is there for, but we don't need to look at that to figure out the problem. That's just showing us what one group would look like. But we have more than one group. So I'm going to cover that top box because this is all we need to look at to find the answer here. So how many groups do we have of 7? How many squares do we have in this bar model? Let me count the squares. 1, 2, 3, 4, 5. So we have 5 groups. And what number is in each group? What number is in each group? 7. The number 7 is in each group. So the multiplication problem is 5 times 7. All right, now let's go about solving it. Make it a little bigger there too. All right, so 5 times 7 means that we're adding the number 5. We're adding the number 7 5 times. So it's basically a shorter way of saying 7 plus 7 plus 7 plus 7 plus 7. All right. So we're going to start out by adding 7 plus 7. 7 plus 7 equals 14. (14) plus 7 equals 21. So now we've added the number 7 3 times. 7 plus 7, we added 7 plus 7 and got 14. That was us adding 7 twice. Then from the 14 plus 7, we got 21. We've added 7 3 times so far. We're going to add 7 a 4th time now. 21 plus 7 equals 28. So we've just added the number 7 4 times. For the problem here, we have to add 7 5 times. So we're going to add 7 one more time. 28 plus 7 equals 35. So after adding the number 7 5 times, we got 35 for an answer. All right, so now I'm going to show you 2 other strategies. If the counting by 7 doesn't work for you, you're not able to skip count by 7s, or you're not able to continuously adding 7s isn't the strategy that works for you, I'm going to do the 2 other strategies now. All right. So now I'm going to make 5 rows with 7 X's in each row. And then I'm going to count the total number of X's. So that's 1 row of 7. That's 2 rows of 7. Three rows of 7. Four rows of 7. 5 rows of 7. So now I'm going to count the total number of x's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. All right. So same answer we got. 35. All right. Last strategy over here. I guess I could use dots. Doesn't really matter which object you use, whether you use zeros, x's, or dots, but I use dots for this last one. So I got 5 circles. I'm going to put 7 dots in each circle. Again, if you're using this strategy, make sure you space the dots out, spread out enough where they're not bunched together. You can tell them apart. If they're too bunched together, it's easy to miscount. Even if they're not too bunched together, it's easy to miscount. You know what? I'm going to make this so it's a little easier to see. 1, 2, 3. 4 there. All right. So now we have to count the total number of dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 21, 22, 23, 24, 25, 26, 27. I might have to count again. I might have miscounted. 28, 29, 30, 31, 32, 33, 34. Now I'm going to count a second time just to make sure I got the right number, especially since the answer is different than the other two. I might have to recount. Oh, look. I thought I saw an extra dot in one of them. I didn't. All right. Well, I'm going to count again. Sometimes it's good to recheck your answer and count 2 or 3 times because it is. I've seen a lot of people set the problem up perfectly and then they miscount and then their answer is wrong, but they're only off by like 1 or 2. All right. Let me recount. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. All right. That's more like it. Now, I know how to multiply 7 times 7 in my head, so I know that's the right answer, but if I'm a student and I counted and I got a different number each time I counted, I would count a third, maybe even 4th time to double check. So for all of you watching, I'm going to pretend I'm a student. I'm going to count one more time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. All right, so 35 is the right answer. So 5 times 7 is 35. So 3 different strategies to figure out the multiplication problem. I recommend you use whichever one works for you. It is a lot easier to skip count. I would definitely recommend if you go to my multiplications live. This video will be in the November Lives playlist because it covers what students are working on in the month of November. And this is what we're currently working on in math during the start of the November month. But if you go to my multiplication lives playlist, you will see all the fact families from multiplying. You'll see multiplying by 10, multiplying by 5, multiplying by 2, multiplying by 3, 4. All the fact families, it'll teach you how to multiply every number 1 through 10. So I would recommend checking that playlist and practice your skip counting. And, I would start with the 10s. 10s are the easiest. Practice skip counting by 10, practice skip counting by 5, practice skip counting by 2. Those are if you're a beginner, those 3, 10s, 5s, and 2s are the easiest to start with. But practice skip counting and solving the multiplication problems within each fact family. If you go to my multiplication lives video, you can practice every day. What you can do is you can pause the video, try solving the problems, and then unpause the video and play the video to see how many you got right and test yourself. Because it is a lot quicker and more efficient if you are able to skip count. As you can see, there are strategies for students that can't skip count. So you can still, even if you don't know how to skip count, you're not fluent with adding numbers, you can still solve the multiplication problems if you use these strategies, but they do take longer and they require a lot more patience because you counting each number individually, it does take a little bit longer. And it does require, especially when you get up to really big numbers, that you might need to count the number 2 or 3 times to check and make sure you got the right number. So again, if you're not fluent with adding, you can use these strategies. They'll definitely work. You can still get every problem right, but it does take longer. It is harder. I would recommend learning how to skip count every number 1 through 10, watching my multiplication live videos, pausing the videos, practicing, seeing what you can get on your own. If you do that 10 minutes a day, you'll improve a lot with your skip counting. If you get to the point where you can skip count every single number fluently, these problems become a lot easier. But that is my math for today. And obviously now, I say obviously for those of you that watched the video before, but for those of you new viewers, I always end with basketball. Healthy body, healthy mind, got to get some exercise in. So I'm about to dunk on this whiteboard. So we'll bring it back here. Well, you know what? I'll do some turnaround jumpers. I got to get a little warmed up first because I'm got to tuck the shirt and hang on. Shirt's tucked in. Here we go. I got to warm up first. So I'm going to do 5 turnaround jumpers, 5 going left, 5 going right. Then I'm going to bring the whiteboard in to get dunked on. All right. Put this chair out the way. All right. Here we go. See, you got to shake off that rust. Here we go. Woo! Being the best, it takes repetition. Doesn't happen overnight. Other side now. Even once you've practiced, really gotten your shot right, you still miss sometimes. It happens. I need to make one more. I'm going for 5 makes on each side. I'm going for 5 makes on each side. I'm at 4 right now. So I need one more. I don't know why I took my shirt in because now it's like out anyway. But here we go. Bringing the whiteboard in and it's getting dunked on. All right, here we go. It's a little different when you got a defender on you. Gotta be careful. They'll call you for an offensive foul. You get a ref that's really. Here we go. All right. One more make on each side, one more turnaround jumper, and then I'm dunking on this whiteboard. Let's go. Basketball is a physical game. It's a physical game. You can't stop me in the post. Dunk on the whiteboard one more time. Dunk on it one more time. And one. And one. Whew, I am getting tired. I don't have that stamina like I used to. All right. End it with a few fancy dunks here. I was going to try to do the whole session with my shirt tucked in, but it's out now. So, you know what? I'm just going to go with it. Dunk time. All right, that is my video for today. Please like, share, post a comment. Let me know if this video was helpful, if you understand the problem, or if you still need difficulty and you need some additional help. Also, if you want to try these problems on your own, if you want to try writing the multiplication problem and solving for each of the bar graph examples I did on your own, what I would do is pause the video so the problem's on the screen on a piece of paper. Try solving it independently, and then unpause the video and watch the steps I used to solve it to see if you did it correctly. So you could do that for all of the problems that I modeled, or any of the problems that I modeled. I hope that helps. Have a great evening, everybody.